because I can talk now. I want to thank Peter again for introducing Resonate, and now we have Tim, a fellow BigchainDB-er, amongst many other things. He's also one of the authors of COALAIP, which is a blockchain-ready, community-driven protocol for intellectual property licensing on the blockchain. So, without further ado.
Thank you. Yeah, so you heard my name already. I started to work for Ascribe about 2 years ago. In May, it's going to be 2 years. Then we pivoted to BigchainDB, and I've been heavily involved into the Koala specification, which I'm going to talk tonight. Personally, I care a lot about blockchains, intellectual property, and since very recently, actually, also about self-sovereignty and how that plays out into blockchain and IP and into identity and so on. I think Peter already mentioned this example, so it's quite a good bridge. I kind of want to motivate my talk the same way, which is that it's really difficult for artists, especially music creators, to make a living of their creations. So this is a website called spotifycalc.com, and it lets you enter the number of streams and then what the creator of those songs actually gets compensated. So what you can see is actually that for Spotify, if you play the song 1,000 times, the creator or the songwriters and the labels and so on, they get $7.20. So it equals to 0.0072 cents per stream. And so if you think about your favorite band that you might have listened to 1,000 times, like back in 2016, is $7? Is that enough, or would you like to give more? I mean, it's up to you, but just as an example. Then, as a second motivational example, I want to bring up this comic. Basically, the web has a big problem with attribution in that it was never built for attribution, and this comic outlines it kind of in a way. As soon as you share something on the web, basically everyone can pick it up and claim attribution themselves again. So for this comic, actually, when you Google it on Google Images, it shows up a lot of times, and so even notice like it's not even the one I used. And the problem with this is obviously that it's really, really difficult to find out the original creator of this comic, and I wasn't even able to find out. It would have taken me a lot of efforts, way more than creating this whole presentation, right? So imagine a Google Images with maybe a button somewhere that allows you to see your contact information of the original creator of that image, or even a way to compensate the creator of the image. And then thirdly, there is this problem actually in the real world that content licensing is incredibly difficult, and especially for a layman or a creator that doesn't have in-depth knowledge into legal knowledge. So here we have a good example, I think, or a quite funny example of I think it's a German artist called Johannes Greitler, and he created a mixtape composed out of 70,000 samples of other tracks, and GEMA's process is structured in a way where for each sample you have to fill out one piece of paper and about the sample, and then you have to submit all of those papers to GEMA if you want to register the song with GEMA. So what he did is he created that song, and then he actually did a performance art piece on delivering like a truckload of papers to the GEMA offices here in Berlin. There is a video of this. You just gotta search for product placements by Johannes Greitler. So to address these problems, COALAIP, first of all, Koala was formed in 2015. It's the Coalition of Automated Legal Applications, and they started to meet 3 to 4 times a year. And eventually the COALAIP working group, which stands for intellectual property, formed. And they started to work on a first draft of a white paper that would allow IP to be handled digitally on blockchains and other immutable ledgers. And we were actually able to release a first draft of the white paper in fall 2016, and we're currently working on a reference implementation of that very white paper. The COALAIP working group is composed of those of some of those people. So there was Ujo, I think, mentioned before. They've collaborated with us. Some people from IPFS, Mycelia, Resonate, obviously, and we from BigchainDB or Scribe, and as well as COALAIP. When we started with COALAIP, we thought we would look at the whole creation process that goes into making a creation. So and this picture should just give you an example of what our data models are, basically. So we start with the author, and the author might have an idea. So let's say you're standing on a mountain and there's a sunset, and now you want to persist this memory of that sunset in some kind of medium or something. So this would be a creation, like that thought of persisting it. And then you have to choose one of those. You have to choose a medium that you can express it with, and once you have expressed it with that medium, it becomes a manifestation. It manifests itself into real life. It becomes tangible. So, for example, you can take a brush and draw that sunset, or you take a camera or a video camera and take a photo or a video, or you describe it, or something like that. And as soon as it comes into real life existence, you have manifestation, and you might want to license that manifestation. You want to derive some rights from the copyright you own and give them to somebody else, and this is the distribution of that creation you have made. So COALAIP's core functionality is composed of the 4 functionalities that are shown here. It's about attribution and provenance of pieces that artists create. It's about the licensing of those creations. Then it's about the distribution. So how can I sell my work to someone else? And then at a later stage of the cycle, it's also about how can it be verified that how can all of these steps be verified by an independent party or by myself or by whomever wants to verify. In the very beginning, we started off with 3 very important goals. Interoperability was one of them, extensibility and future-proofness or upgradability, and the whole protocol to be auditable. We quickly noticed actually that leveraging the existing technologies that are being developed right now in the open provide a super powerful baseline for what we wanted to do. And I'm going to go into details into each of those goals and explain you what I mean with leveraging powerful technologies. So interoperable. Currently there is a lot of blockchains and other ledgers being deployed onto the internet, and this kind of reminds me of a situation that maybe happened like 30 years ago, where you had all these different subnets at the universities in the US that were only talking privately by themselves. They were basically contained, and only when TCP/IP, a network protocol, was invented by Surf, they started to communicate with each other, and so out of all of those nets, basically there grew this big nets out of nets, which is the internet today. And so interoperability on blockchains, it's not yet solved because nobody has like 100% figured out everything, but we kind of have a few technologies which you can apply to those ledgers that make them speak to each other, and we really want to leverage that. So it's I stole, by the way, no, I didn't steal, but I made this logo myself. Because they don't have one yet. So it's IPLD, it's JSON-LD, and it's the Interledger protocol. And I'll go into detail why. JSON-LD helps operability because it allows us to link JSON objects from within a JSON object. So what you can see here, for example, is that I'm taking the author property, and I'm linking to some content addressed, some other content addressed JSON object somewhere. Then IPLD allows the Merkle linking of JSON objects, meaning that you can make your content addressable, meaning that you can query by hash. So what happens here, for example, and it also implements a Merkle tree, meaning that for each individual property of that object, it's going to get hashed, and then bottom up the hashes, like there's a Merkle hash created. This allows you for optimized verification of that whole object, and it also allows you to, well, as I said already, content address, and it allows blockchain agnostic querying, and I can show you how, or I can. This is very it's not there yet, but it's gonna be there soon. So what you can do, for example, is you can do IPLD resolve, and you can see that there is an IPFS link here, and that IPFS link queries some hash content. And what I didn't tell you before is that the hash that is here is actually this object. And when we look at the URI again, we see that we query after that, we query the author. So what would happen here, it would again traverse into this object, go to the author, and remember, we're still on IPFS. But then at the author property, we're going into another ledger, which is IPDB, but can be any other ledger that implements IPLD. And from we resolve it on IPDB, and what we get is an object with a given name and a family name, so Andy Warhol. And then third of all, there is interledger, which enables actually cross-ledger transfers. So this is also more visionary than what actually exists, but still what we would like to achieve here is the transfer between, or maybe even the escrow transfer between a license, for example, a streaming license could be it, and some kind of currency. And so what this example does here is it sends to the Ethereum public net to Alice an amount of 1,337 currency units, and we have attached a memo to that saying that we want this right to be transferred to us. We also have an execution condition that is this whole thing in a hash plus some challenge, and we have an expiry date. So what we're doing basically is we're putting this money into a hold account, and then we're waiting for Alice to also put their streaming license into a hold account. And as soon as both things happen, there will be an execution, and both of the trade units will have changed owners, which is nice. So we have an escrow between money and a streaming license, for example. So that's interoperability. For extensibility and future-proofness, there is mainly one thing, which is RDF as a data data storage format. It gives the biggest benefit to us by providing really strong base models and allowing us to subclass from various other models. So what you can see here, for example, and I'm going to demonstrate this later on as well, is that we define the COALAIP manifestation, and we actually we subclass it from schema.org's creative work. And if you look into the creative work of schema.org, there is actually subclasses of book and a subclass for a musical track and so on and so forth. So all of these different mediums are already contained inside schema.org. So you basically just have to apply it. This is really powerful because we know that IP licensing will not work with a single data format. There is, and I'll go into details later about that. A quick note about the models, just to introduce them to you. As I said, we started with the author. It's basically a subclass of the schema.org person model. You can put a lot of information. You don't have to necessarily though, because not all the information is required. Then what we can do is we can register a creation and append or link back to the author, so we get attribution. And once our idea has manifested itself into real life, we can upload it to the internet, point to it. So, for example, we could put it on IPFS, but we can also put it on our website, and we just use like a regular HTTP URI to link it there. We can also attach a location where it was created. We can actually use all of the fields that creative work of schema.org provides us. And what we can also do is we can apply a fingerprint to that manifestation in order to uniquely identify it amongst other works, for example. So for digital fingerprints, though, it's right now, I think we're on a very low level on how they're being used, and we would actually like to see much more usage of them. Oftentimes, people just use a regular hash function. They take the file, they take all the bytes, they put it through the hash function, and then you get a unique identifier. But as soon as someone manipulates a single byte on, for example, that picture that you just hashed, the resulting hash gets completely replaced, right? And the result is a completely different hash. There are other solutions to this problem, though. There is actually a lot of libraries that implement some kind of perceptual hash where the program looks at, I don't know, the picture or the audio file or something else and tries to identify other unique characteristics apart from bytes, and then composes that into some kind of number or string or something. And what we would like to see, especially for COALAIP, is that people are not only using regular hash functions, but also more advanced hash functions to really like clean up the whole ontology, link things together, so on and so forth. Then, almost last but not least, we have the write. So, okay, now you had the idea, you claimed the attribution, you submitted the file, and you added a fingerprint. Now you want to distribute it, so you add a license, and that license you can add actually as many licenses as you want. So maybe you want to sell your work commercially, then there might be a different license applied to it as when you want to sell it to a friend. You can specify all sorts of things. So you can specify the usages of the work, so how it should be used, the territory where the rights apply, the context also where the rights apply, the exclusivity of the license, and most importantly, you can also define the license itself. So this is not a fully computer readable license. This whole thing, the actual license with terms of services included that will be required when you go into a courtroom or something is actually included here in the license property. And this is supposed to be a human lawyer readable document, because we believe that by tying like computer technology or blockchains with with the legal world together, then we get a really powerful construct. So I've done that here. I've included the ascribe.io terms of services, a specific subheadline of that, and that would outline when I receive a certain license for a work, that would outline my rights and my usages. Something that's interesting is that all rights in COALAIP are basically derived from copyright, which is you gotta imagine it like a big bucket of rights that is handed to you as soon as you create something. And you can pull out all kinds of rights, compose them into a license and send them away. But other people, actually send a bucket, and other people can take things out of that bucket and send them away again, if at least like in certain terms. So for example, imagine you would receive a license that would allow you to publicly display a work, and also a right that includes to publicly display the work, and also has the right in it to transfer the work. you can actually split those two things apart in another transfer and transfer them individually. I'm not a lawyer, anyways. Yeah, that's the right transfer. So exactly. So if you want to transfer a license, for example, you would just use the asset functionality of the blockchain you're using, and you would transfer that license to someone else. But you can append, if you want, you can append more licenses in that transfer. So RDF is mainly used, as I said before, because we want to create brand-specific models of different industries' use cases. Because we know that for licensing music, it's very different for licensing, for example, books. And I mean, this is kind of a toy example, but it's obviously much worse. A musical track or an album is vastly differently licensed. The data models, the underlying data models, would be totally different. What we want to provide with COALAIP, though, is this base layer of IP licensing so that everyone else can derive their licenses and build on top of us. So that when you create an album, you can not only license the songs, but you can also connect the whole album to the person that did the album cover. So yeah, that's the idea behind that. COALAIP is based on some big players' ideas. The Linked Content Coalition is an open standard that was that enabled actually DDEX and Plus to grow. DDEX is the go-to player for all, like everything technical music, basically. They do not only, it would be too much to say, but they have like, I don't know, they do everything in the music industry, they digitalize everything. And also Plus is really, really huge in providing standards for stock photo licensing. Yeah, so the Linked Content Coalition, they came out with a paper that is called Rights Reference Model, and the COALAIP protocol is based on that. And what I'm trying to say with that is that obviously we want to tie into those constructs because everyone is using that, so we want to have compatibility with them. About auditability. So now we're on a blockchain or a ledger, a continuous ledger, meaning that all the data you write, it's append only. You can never delete it. So what happens when fraud intentionally or unintentionally is committed? Well, in this case, it's in this example, it's not fraud, because yeah. But imagine the situation where Andy Warhol had the idea for 32 Campbell soup cans. He actually also had the idea to create a poster out of that, and he registered all of that in COALAIP, appended a license, and then for whatever reason, because maybe his program was incorrect or something, he also claimed to be the author of the screen. Well, obviously now this is not a correct statement, so we have to do something about it. So what COALAIP allows us to do is to make write conflicts, which is an object that can point to another object and refute the statement, or we can do assertions. And all of this is based upon a trust model, kind of, not quite, but kind of similar to some kind of reputation system like the Web of Trust. So, for example, the Museum of Modern Art of New York could go into the ontology, look for things, and then find out that Andy Warhol claims to be the creator of 32 Campbell soup cans, and they say, cool, that's correct, because we know we're like a big institution, maybe we even own it, I don't know. But they also know that the screen is not from Andy Warhol, but from Edward Munch, so they would refute that whole claim, and since it's the MoMA, it's kind of theoretical to say that, but since it's a MoMA, they would obviously have a higher score than, for example, a newly registered user into the system. So everyone would put more trust into the MoMA than into just some random person submitting some claims. All of this to say, though, that the data modeling is not enough. there needs to be a front end or some kind of aggregation of all of these facts to make sense for a human being, because it's not going to be 2 claims, it's going to be thousands of claims. And then the aggregation should be the source of truth that is presented to the end user. We faced some challenges with COALAIP, or we're still facing challenges with COALAIP. For once, it's directed graphs of immutable ledgers, meaning that you can, obviously, you can never point into the future, because first of all, you don't know what's happening in the future, and second of all, since it's immutable, you can never update to point in the future. So we always have to, like, when we append, we always point backwards, right? So this leaves us with one problem out of theoretical computer science, I guess, which is node discovery. How do you discover a node that is not very reachable? So I try to visualize this with the red arrows. Actually, all the links go up, and then what could we do to discover the fingerprint when we're at the creation stage, so the light bulb? We kind of have some ideas, but if you have input, that would also be helpful, obviously. Obviously, graph search algorithms, some kind of, would be awesome if blockchains would allow for querying and keeping external indices to, for example, a timestamp would also be an option. Amazing, right? My drawing skills. Interledger currently only allows the exchange for fungible assets, and fungible assets are assets that where the individual units can be mutually substituted. So in this case, for example, imagine you would trade or you would buy a full barrel of oil. Then you wouldn't care about which barrel they hand to you at the cashiers, right? Whereas when you buy a record, you really want to buy that record you chose. So it's not mutually substitutable, right? So that's how you define a fungible asset. And Interledger currently only allows for fungible assets to be traded in between 2 players, because this makes it much more easier to establish an exchange, a middleman, where the rate is just one single number, kind of like as on the stock market where you have 2 currencies and then there's the rate in between. And for records, this doesn't exist because there needs to be some kind of matchmaking or discovery between the 2 players, kind of like eBay, right? So that's a problem. And then there is one big missing link, which we're currently looking into, which is identity. Identity is currently managed not very digitally. It's managed by various actors, various big players. So I would personally say it's managed top down. So it's Facebook, it's government, it's Twitter, LinkedIn, so on and so forth. And what we would like to see, and it's actually it even has a name. It's self-domain identity, same domain identity, meaning that for each application there is on the web, you have your own identity, which is a username. You have your own identity, and that is attached to your credentials, which is your username and your password. So you have one for Facebook, Twitter, and LinkedIn. But what we're actually looking for is an identity system that is in the ISO-OSI stack, one level below the application, so to speak, application independent. And there's people working on this, gladly. There is a big group of people called the Rebooting Web of Trust conference or working group. They're working on so-called the self-sovereign identity. They have papers about their principles and all this. It's a very much bottom-up approach where the individuals themselves make claims about other people and manage the identity between themselves instead of big players managing all of the individuals. That's almost it. So COALAIP basically does two things in order to fulfill its core functionality. It provides it provides or it enables a community-driven data definition approach, and it also enables to create branch-specific data. And additionally, it's an open IP protocol for license transactions, and it does the verification in between. We have a website now. It's COALAIP.org. We have licensed all of the content that you can see under free and open licenses. So the white paper, the specification is in Creative Commons. We also created 2 Python libraries that are under the Apache 2 license. One is PyQualAIP, which allows you with Python to create the models I've been introducing. And we have created a so-called ledger plugin that allows you to persist these models once they come out of PyQualAIP onto various ledgers. Right now it's only BigchainDB, but we would love to see solutions for IPFS, for Ethereum. I think Ethereum should also be quite easy as well as IPFS, or even Bitcoin, I don't know. Yeah, so that would be awesome if somebody did that. That's it. Thanks for your attention, and if you have questions,